Going to talk on Python and Raspberry Pi. Sudar builds robots as a hobby and has given talks on how to interact with hardware using various technologies and tools. For his day job, he works as a research engineer at Yahoo Labs. Welcome, Sudar.
Okay, first audio check. You guys are able to hear me? Front rows, middle, back rows? Anybody from back row? Am I audible there? Okay, great. As you can see, I don't have anything to project. That's because my Raspberry Pi is not connected, and I'm going to connect it. Hey, is this projector connected? And I'm going to keep my fingers crossed, hoping that this works, so that I don't have to bring my laptop. Yes, this works. So as you can see, just Raspberry Pi is booting up. Okay, let's just give it a minute to boot up, and then we'll have the slides. Okay, it has booted up. Now that it has booted up, let me load the slides. So there is a running joke about connecting USB devices. It takes you 3 tries to connect a USB device. And okay, so we have our slides. Let me connect the keyboard back. And we are good to go. Okay, so first a couple of words about me. I work as a research engineer at Yahoo Labs, and these are my hobbies. My latest crush is on Raspberry Pi. I've been playing around with it for quite some time, and so I thought, and just one trivia, how many of you know what Pi stands for? Raspberry Pi? Python, yes. So PyConf came out, and I thought, okay, let me talk about how we can use Python in Raspberry Pi. Okay, and that's how I got started with this talk. And I was preparing my slides, and I thought, wouldn't it be really interesting if I can do everything from Raspberry Pi instead of bringing out my laptop, connecting it, and then doing all this stuff. And that's how this crazy idea struck me, and I converted my slides to PDF, and Raspberry Pi had a built-in PDF viewer. So there you go, you have the slides, and it works. Works? Yeah, it works. Okay. I love Python, both the animal as well as the language. And yeah, this is a real Python, by the way. So I've been using Python for quite some time for my hobby projects, and also hobby projects at work. I mean, what do I mean by that? It's not in production level, but some quick prototype if I have to build. I've been using Python for quite some time. And today, what we are going to see in this presentation is about how you can use Python in Raspberry Pi, especially concentrating on the parts where you can control the hardware. Okay, not just about using Python, because Raspberry Pi, as you know, probably is just it's just like a unique Ubuntu machine, right? So Python is there by default, and you can use all the packages. But just that, how you can control hardware, right? I mean, that's what we are going to see about today. And yes, what is a Raspberry Pi? So how many of you own a Raspberry Pi here? Good. How many of you have heard about Raspberry Pi at least? Okay, I think do an inverse now. How many of you have not heard about Raspberry Pi? Very few. It's really good that Raspberry Pi is gaining traction. Okay, so for those who don't know, it's a credit card size computer. If you can see, it's just like this size. It can fit in your pocket. And so this is an SD card which acts as a hard drive. Okay, and it can get powered by most of the mobile chargers. It needs 5 volt 1 ampere current, and it has an Ethernet built-in Ethernet port, so it can connect to internet, and it also has 2 USB ports. You can use USB hub to extend it. You can practically, I think, connect 138 devices, USB devices to it. It also has an HDMI output. You can connect to any HDMI enabled device, a monitor, TV, those kind of stuff. You also have audio, all those things. Okay, and what we would be really interested in today is this part. This is where the GPIO pins are exposed. Okay, that's where it's going to get. It's slightly different from a traditional computer. A traditional computer, everything is boxed down, so you don't directly connect to the hardware, right? So here that is exposed, and we'll see about that. And for the next slide, some basic electronics. I hope like all of you know about, or how many of you know about voltage, current, resistance? Good. And can anybody guess what this looks like? Yeah, I don't have to talk about basic electronics, I guess. Okay, so couple of words about voltage, current, resistance. So voltage is like the difference, or you basically have to connect a battery or a power source. That's where you get the voltage from. And the circuit, the flow of electrons is called current. I hope all of you know about that. And then we have this element called resistor, which tries to resist the flow of current. And Ohm's law is there. So we have this law which says V equal to IR, basically voltage equal to the product of current and resistance, all those things. And believe me, to try out all the demos today, you need only that, V equal to IR. Okay, and you don't need anything more than that. And while we wait for the next slide, yes. So as I said, what we are really interested today is the GPIO pins. Okay, so Raspberry Pi has a couple of GPIO pins exposed. There are like a lot of headers. So this is called P1 header, and here the pins are soldered. There are also a couple of other headers where the pins are not soldered, but you can solder it if you have a steady hand and have soldering skills. Okay, so what we will see today is how you can access these GPIO pins from Python. Okay, how you can read the status, write it, and control devices which are connected to GPIO pins and things like that. Okay. Okay, so setting up Python, not just Python. I mean, Python comes by default in the operating system which you're going to install. What do I mean here is setting up Python so that you can access GPIO. Right, so you just need to install 2 packages. One is the Python dev, and the other one is the Python-raspberry pi.gpio. And so, as I said, this is Raspberry Pi, or the Raspbian operating system which is there in Raspberry Pi is a Debian port. Okay, so you can use your favorite apt-get to install packages. You can also use Aptitude if you're an Aptitude fan instead of apt-get. So you just need to install those 2 packages, and you are done. Okay, you don't have to do anything, and you should be able to access the GPIO pins. Okay, and yeah, so this is the first demo which we are going to see. Okay, and there aren't much slides anymore. I'm just going to be showing some code and showing you how things work. Okay, so this is Raspberry Pi. As I said, these are the pins which are available here. Okay, and here we're going to connect an LED. So before we get into this, how many of you know what is an Hello World program? Hello World program. Good. So what it is? Can somebody tell me? Sorry? Yeah, it's the simplest complete program which you can try in any language so that you get a feel of the language, right? In the software world, what you generally do when you learn a new language is to try to write an Hello World program. In the hardware world, what you try to do is make an LED blink. Okay, that's like the complete, simple, complete program which you can do so that you get a feel of how things work. Okay, and that's what we're going to do now. We're going to write an hello world in hardware. We have an LED and we are going to make this LED blink. Okay, so again, Ohm's law coming to picture. Raspberry Pi works on 3.3 volt, and the threshold, maximum threshold voltage of a resistor is around 1.7 volt. So we need to make sure that we put in some resistor so that the LED doesn't, instead of blinking, doesn't burn. Okay, so that's the resistor here. So if you use the calculation V equal to IR, you shift R equal to V by I. So the voltage is, the difference in voltage is 3.3 minus 1.7 by the current, which is going to be 50 milliampere. So you get roughly some resistor. I just put 250 ohm resistor here instead of doing the calculation because that just works. And okay, so once we have this circuit, what we need next is the code, and this is just the code which we need. Okay, so there are some import statements. I'm just going to import the GPIO module. After I import the module, there are the first statement which says set mode, right? So what we are doing here is, as I said, the Raspberry Pi has these GPIO pins enabled, right? So each of those pins are actually connected to one of the pin in the microprocessor. Okay, so there are two naming schemes by which you can access those pins. One is by the order in which it is exposed in Raspberry Pi, or the way in which it is connected to the processor. Okay, so what I'm going to do, so if you don't want to look at the schematics and all that, just say I'm going to use the board layout, which is how the pins are available in Raspberry Pi, and then just go ahead and use it. Okay, that's what I'm going to use here, and I'm going to set pin number 12 to output mode. Okay, so which is GPIO.out, which basically means I'm going to write something to the pin instead of read something from the pin. I'm just going to write something, and this is a typical while loop. So I'm just going to hit it infinite number of times till we actually kill this program. And what I'm going to do here is I'm going to just go and say set the pin 12 as high. Okay, so as you know, in binary, right, we have 0 and 1. 0 is the absence of current and 1 is the presence of current, right? So in the pin, if you say high, it means there's going to be current, which is 1, the binary 1. And when you say GPIO.low, it basically says that you're not going to set any current there, which is 0. Okay, so we're going to do this infinite number of times. Okay, and then we also have a sleep, which is basically going to make this program halt for 1 second. So what you're going to do, you're going to make the LED on for a second and then off for a second. So when you do it infinite number of times, you're going to see that the LED is going to blink. And when we close the program, I mean when I say Control C or something like that, we're going to come out and then we're going to call something called cleanup, which basically is going to release the GPIO pins back to the operating system. Okay, so let's first try this program. I'm going to open the console here. By the way, is it visible? Visible? No? Yes? Yes? Okay, great. So this is the program which I showed in the slide. Okay, so we're just going to execute this, and before that, let's connect the pins. Okay, so in order to make it easy, I just created a custom board. I just soldered some LEDs to it instead of using a breadboard, because I have to keep doing it every single time. So I just have a LED connected with a resistor to a pin. So I'm just going to connect it to Raspberry Pi now. I need to refer to the schematics just to make sure I'm not connecting to the wrong pin. Okay, so we are connecting it to pin number 3, which is ground. Okay, so now that I've made the connection, let's go ahead and execute the program. Sudo led blink.py. So if things have gone correct, then the LED should blink. Yeah, I've entered the password, so it is blinking right now. Can you see? Okay, great. So we have successfully did the hello world program. And so let's slightly modify this. Okay. So what we did here is we are making it sleep for 1 second, right? So let's change this to 5. So it will be on for 5 seconds and then off for a second. So let's do that. And it should be on for 5 seconds, is it? 1, 2, 3, 4, 5. Off, yes. Okay. So as you can see, there is a slight deviation in the second which Python is counting right now, right? So we'll get back to that sometime later in the slide. So that's one of the limitations of using Raspberry Pi to control hardware. Okay, I'll get back to that at the later point of the slide. Okay, now that we said we have light and we got light, let's move on. So blinking an LED is fine, but if you want to connect some other device, let's say you want to connect something like a motor or something where you want to vary the speed, right? You don't want to just say 1, 0, but you want to vary something, right? That is in the hardware world, that's called PWM, pulse width modulation. So you don't have to get into too much on the electronic side, but what you need to do is, what you need to know from a software angle is that you need to use PWM and you need to know what is the duty cycle, and you can safely assume that the duty cycle of 50 Hertz will do that for you. Okay, so that's what we're going to do next. What we're going to do is, since we have the LED already wired up, we're going to change the brightness of the LED. Okay, so instead of the LED being bright and on and off, it's going to be going to a gradual state where it will slowly get into peak of brightness and then slowly fade off, and then that will go in an infinite cycle. Okay, and for that we need to use PWM. So the first two statements I think is same from the last program, where we set the mode of where we set the pin mode and also set pin number 12 as output, and this is the statement which is changed here. So we just need to call PWM and we need to say which pin and what frequency. Here we're going to just use 50 Hertz. Okay, and we're going to start and we're going to get into this infinite loop, and for range from 0 to 101. So basically from 0 to 100 we would increase a step of 5, so we'll go up high in the frequency, and here we'll just come down. So it will be like the LED will go up in the brightness, it's like a sine wave, it will go up and then come down like this. Okay, so let's see that in action. So if you note the LED here, it should, so as you can see, it goes high in the brightness, it's coming down and it will go up. Okay, so here I'm demonstrating this with an LED, but you can use this to control other devices where you need to vary the speed, right, or vary the voltage like a motor and things like that. Okay, so let's close this and move on. Okay, so I hope you all saw the LED change the brightness. So far we talked about how you can write something, right? So it's like outputting something. So if you want to read something back from the external world back into Raspberry Pi, that's when you need to use the input, the pin in an input mode. Okay, so that's what we're going to see here, and the same import statements. And after that, what we're going to do here is we have connected pin number 11. Okay, and I'm going to set the pin mode to be in, and the third argument here, which is basically says the pull down resistor. Okay, so there is another important concept in electronics, which is called pull up and pull down resistor. Any electronic guys here who can help me out with the explanation? Can somebody tell me what is pull up, pull down? Higher voltage. Pull down, you connect to the down voltage. Exactly. So if we see the circuit, I think it should be clear. Okay, so here what I'm going to do is I've connected a button, okay, to the pin. So the characteristics of the button is that it has 4 terminals. Okay, by default these 2 terminals are connected and these 2 terminals are connected when the button is not pressed. Okay, and when the button is pressed, all 4 are going to get connected. So what I'm done here is I've connected the power source to one of the terminals, and the other we are connected to a GPIO pin. So when the button is not pressed, what is going to happen is this is left out hanging, right? I mean, it's not connected to anything. So the GPIO pin could read it either as an high or a low. It is left hanging. In electronics, that's bad. You should not leave a pin to be hanging. So what you do is like you connect a resistor and then connect it to ground. Okay, but since we being software guys, we don't want to get into too much electronics. What Raspberry Pi has done is they have a built-in resistor, and to enable that, you just need to enter that statement which I showed you in the previous slide. That you basically have to set the pull down resistor. When you enable the pull down resistor, you don't have to really worry about how the pin is connected, whether it is left hanging and those kind of stuff. Okay, so yes, so what you are doing, the same infinite loop, and we are reading the input pin number 11, and if it is on, we're going to say button is on. If it is not, we're going to say button is off, and we are going to read it every 0.1 second. 0.1 second is what? Every millisecond, microsecond. I don't know. Every 0.1 second. Let's see that in action. So I'm going to, in this board I have also soldered a button. So I'm just going to connect that. Okay, now that we have it connected, let's run the program. So this is the program which I showed you in the slide. So button is off, and I'm going to press it, and it's on. So that's how you read or use a pin as an input mode. So here I'm just using a button. It could be anything. You could connect it to a sensor, which basically detects whether there is enough light in this room, or you could also connect it. Use this as a relay and connect it to an external circuit. Anything you can do. Okay. Let's move on. Where are we? Yes. So this is the button circuit which I told you about, and what happened when I pressed the button? What happened? Yeah, we got the message printed. Okay, so we saw about using the pin as output mode. You saw the pin about using it in input mode. Let's combine it together. So what we're going to do now is like when I press the button, I want the LED to be on. When I leave it, I want it to be off. Those kind of things. Okay. So this is very similar to the previous program. The only line which I added here is this. I basically set, instead of printing it on and off, I'm just going to set the pin, the LED pin on or off. Okay. And I've just added that pin as the output mode. Okay. Let's quickly test this program. This is going to be the circuit. This is going to be the circuit. Okay. Let's quickly test this. Okay, by default the button is off, so the LED is off. So if I press the button, it's going to be on, and it's also going to be printing the message. Okay, thank you. Okay, now that we've seen these demos, yeah, by the way, you all know what happened now. Okay, so these are like the basic things, right? What you can do. So the reason why I've took these very basic examples is to demonstrate the fact that these are things which are possible to do, and these are the simplest things, right? So these are like the building blocks. So you can build anything on top of this. For example, the talk which is going to come after next to me, they have built a robot based using these concepts. They would be demonstrating that. So yes, so what else we can do with this, right? So Raspberry Pi has a lot of protocols. I mean, you can use these GPIO pins to do a lot of protocols like I2C, SPI, serial. So you can use these protocols to talk to another device. For example, if you want to talk to an Arduino, you can do that easily. Or if you want to talk to a BeagleBone or any of these other things, you can easily do it. Okay. And apart from that, what else you can do? So initially I also wanted to show you something with a webcam. So I had a very old webcam which has a USB interface. So I connected that, read the frame, did some OpenCV stuff on that, and those kind of things. So you can do that. So you also have something called Pygame, which provides, this module provides a lot of functions by which you can easily use it to read frames from a webcam. You don't have to write much code. A lot of examples, and then you can really get fancy by using OpenCV. OpenCV has both object recognition and object what is the other term? Object recognition and object tracking. So you can do all those fancy things. You can do face recognition, those kind of stuff. And recently they also have these GPIO pin enabled webcams, or it's called PyCam. So you can use that as well. So you can use it both on the USB interface as well as using the GPIO interface. And this is one of my favorite because this slightly relates to my day job as well. You can use these Raspberry Pis as a cluster and then get into distributed computing, something like Hadoop. So you can get these things done. For example, this Raspberry Pi is going to cost me just $35. So you buy a lot of them and stack them together. You have your own Hadoop setup. Okay, so people have even ported Hadoop to it. But if you just want to get started, so there is this link where they show you how you can use a couple of Raspberry Pis connected to the same network as a distributed machine and then do distributed computing. So if you have one task, how you can split it up and then give one chunk of the task to one Raspberry Pi, make it complete and then get back, those kind of things. So it's like really fancy things which you can do. And so not everything is rosy. There are some limitations. Okay, so the major limitation, especially from a hardware perspective, is that there is no built-in analog to digital converter. What do I mean by that is, if you have used Arduino, you know that you can plug in an analog sensor and then read values. That's like, if you want a LDR, which is a light dependent resistor, which is a light sensor, right? So that is not going to give you a 0 or 1 like a button, but it's going to give you a range of values based on the intensity of the light. So for that you need an analog to digital converter, but that is not available right now in Raspberry Pi, or that's not built into Raspberry Pi. you might have to use analog to digital converter IC or something like that. Okay. The other problem is you cannot run inductive load. What do I mean by inductive load is some device which requires a lot of current, like a motor or things like that, which requires a lot of current, because every GPIO pin is going to give you only 50 milliamperes. Okay, so you can use a relay to control those devices, but you cannot directly provide the current as well as for those devices. And the other thing is it's not real time. So when we counted for 5 seconds, right, to slightly higher, the reason is the Raspberry Pi right now is loaded up, or the CPU is on a heavy load because I am running a couple of processes, and because of that, you cannot accurately measure the time. The millisecond, those functions are not going to be very accurate. It will be accurate to an extent, but not very accurate. So you cannot use it for real-time applications. But on the other hand, if you take Arduino or something like that, where the microcontroller is doing only one thing, then you can get very accurate time measurement. Okay. The other thing is there are no safe circuits. What do I mean by that is Arduino has a lot of these safe circuits where even if you connect the pin wrong, to an extent it will still protect your Arduino. But Raspberry Pi does not have those many safe circuits built inside it. So you have to be slightly careful when you connect something to Raspberry Pi, because you might end up destroying it. And the other practical problem is that it operates at 3.3 voltage, whereas most devices operate at 5 volt. So you would need a voltage regulator or something like that to make sure you connect those devices and then communicate with them. And so to overcome this, what you can do is you can actually use a Raspberry Pi and an Arduino together. Okay, so if you need to do any inductive thing, or if you have to connect a motor or something like that, you can use Arduino for that, and you can control the Arduino or send the on and off signal to Arduino from Raspberry Pi. So you can combine both and then get the best of both worlds. Okay, and that's it. So these are links from where you can get the source code. So all the source code which I showed today, you can get it from there. You also get those fancy circuit diagrams. So if you have a Raspberry Pi and just want to quickly try things out, you can use that. And this is my blog where I blog about my experience doing, or my fun, or the fun I get doing hardware stuff. And this is a reference to the GPIO module. So there are a lot of functions which you can use. And this is the link about distributed computing. So I'm going to post this slide. I'll probably tweet about it in a couple of minutes after this talk, so you can take it from there. And thank you all for being a very good audience. Thank you. So I'm not sure if you have time for questions.
Yeah, it's time for question and answer.
So yeah. So any questions? Feel free to ask me.
Hey Sudar, thank you first of all. And how different is Pi from a Arduino kit?
Yeah, so that's what I was trying to get at. So Arduino is something which is purely only for hardware stuff. Raspberry Pi, on the other hand, is like a desktop computer which can also do hardware stuff. Okay, so the main critical part is going to be, if you're going to do anything which is real time, you cannot depend on Raspberry Pi for that. On the other hand, if you need to make or if you need to interact with the internet, right? If you need to make a lot of internet, or if you need to talk to the internet server or to a network, you can still do that in Arduino. You have to either have an Ethernet shield or a Wi-Fi shield, but things might get a little complicated there. So in those cases, you can use Raspberry Pi. Okay, I would say these are two different things which can solve two different problems, but there is one small common place where both meets. But it would ideally depend on your project. I would say for most projects, it's very clear whether you want to use a Raspberry Pi or an Arduino, but there are very few projects where you might be able to use both.
How successful is putting an Arduino along with a Raspberry Pi to maybe control a hardware which runs on direct power, where a power relay can also be used? How successful are?
So I would say it's very successful because it's very easy to do as well, and that's how you should do things. Yeah, that's how you should do things as well, and it's very successful. I wouldn't say, I don't know.
Or rather, how effective is it?
It's very effective. I would say it's really, really effective if you can combine both Arduino as well as Raspberry Pi together. I guess even for the next talk, these guys who have built a robot, they have both Raspberry Pi and Arduino talking to each other to do things. So that's the recommended way if you ask me, if you're going to have a lot of inductive load. Any other questions? Yes.
Yeah, so I wanted to ask about how the Raspberry Pi fares against the BeagleBone Black, because Black is the new installment from BeagleBone. It's comparatively the same price to give or take 100 rupees. So I want to know how it fares against it, because Black comes with something known as the Bone script, which seems more easier than using the GPIO library for Raspberry Pi on Python. So I just did a bit of comparison. Though I love Python, I felt that the Bone script was better in this case.
So I would say both are very similar. When Raspberry Pi just came out, Raspberry Pi had a real advantage because of the price, and the BeagleBone guys really wanted to catch up. So now they have reduced the price for the latest board. The price have reduced. I would say if you're going to compare the latest BeagleBone with Raspberry Pi, there's not much difference. As you said, if you're going to use Bone script, it's going to be really easy for you to do stuff. Okay, but on the other hand, the adoption rate for Raspberry Pi, I would say, is like slightly higher than BeagleBone. So there is a very niche community for BeagleBone, but pretty much everybody is using Raspberry Pi. What do I mean by everybody? Is like people from multiple segments. So this is getting used in schools. This is getting used by people who want to connect it to their TV, or it is also being used by hackers. So there's like a multiple different segment of people who are using it, and this is more or less becoming like a commodity these days, like a full-fledged desktop. So that would be the difference.
And the Raspberry Pi is not completely open source, is it? As in, there are parts they haven't revealed the GPU.
Exactly.
Unit?
Yes. Exactly. Even the I think the data sheet for the microprocessor which is used in Raspberry Pi is not open source.
So Broadcom has.
Yes. So the reason they say for that is they wanted to keep the price as cheap as possible, so they did that. So if you have the philosophy that you want to use only open source hardware, then you might probably have to go with BeagleBone, because there I think even the entire schematic, everything is open source. That's not the case with Raspberry Pi.
Yeah, and this is not a question, just one more thing. Have you heard of the Pinocchio board?
Sorry?
The Pinocchio board.
I've heard about it, but I have not personally used it.
Just have a look at it. It's amazing for distributed sensor networks.
Sure, thanks for the reference. I'll definitely have a look at it. Yes, somebody had a question
Hey, good morning. So, how does exactly this works in distributed computing? So, how do I manage the workload for different boards? Say, suppose I have 10 boards.
Okay.
Then I want to send signals to, like, based on the workload that the first node has, I should delegate the the task to the other boards.
Okay, so I will probably give you a very high level picture of how you can do that, but if you need more information, we can talk offline.
Yeah, sure.
On a high level, what you do is like you have to have one or two nodes as the master node, okay, and the others are slave node. The slave node should have to keep pinging the master, telling that, hey, I'm up, give me some task, and also the CPU load or whatever. And whenever there is some task, the master has to split it up and then give to these slave nodes. And and then when the slave node comes back, you can do this. And if you want to, so this is like the simplest use case. But if you want to also get into fault tolerance, things like what Hadoop has done, things might get a little complex there. But high level picture is that there has to be a centralized master node, which would control different slave nodes. Yes, exactly. Hey, I think we have time for one last question. So, yes.
Hi, I'm doing a project on Raspberry Pi. So I have 3 questions.
Yep.
I'm doing it on a home automation, so the Raspberry Pi needs to be always on. So is it possible, or is it good to keep it as a?
Yeah, I think it's possible to keep it on. I think the record for the most uptime is it's close to a year or something like that. And I think the only reason why that got switched off was the power supply was off or something like that. So as such, Raspberry Pi can be kept on for years without any issues, unless until you provide proper power supply to it. I think it will be fine.
Is the Raspberry Pi module used in? Is the Python module used in Raspberry Pi is different? I guess something Pi. It's called.
No.
Is there something extra other than Python we normally code or something?
So there are actually different modules which you can use. What I picked up is the rpi.gpio module. I think there are a couple of more modules to it, but this one is the most popular one. That's the reason why I picked it up.
That's
Okay. Once again, thanks everyone. So if you have any questions, feel free to talk to me offline. And we need to shut the Pi. So let's do that.